Alright, so I think this is recording. Let's almost knock that off. Let's take a look at this tide problem. The time between high and low tide in a river harbor is approximately 7 hours. The high tide depth of 16 feet occurs at noon, and the average harbor depth is 11 feet. Write an equation uh, that models this relationship. Alright, so the high tide, my maximum, so my units in Y are in feet, and the high tide is 16. If the average is 11, that's telling me my center line. Now I'm 5 units above or 5 units below that. 5 units below that, and I'm at 6 feet. So 6 plus 16 plus 6 is 22, and the average, take divide by 2, and I've got 11. So that makes sense to me. Alright, now the time between high tide and low tide is approximately 7 hours. So the time that it takes to go from high tide to low tide is the same like the time it takes from low tide to high tide there, and that's 7 hours. Alright. So if half of the period is 7 hours, because the distance from the min to the max, or from the max to the min, is half of the period, then that means my period is 14 hours. And a fourth of the period is the distance as you bounce from the center line to here, and then back, going back and forth. Alright, so 14 divided by 4 is 3.5. Alright, so if we pick a starting point that's on the center line like that, if we call this time t equals 0, then 3.5 hours later we're at a max. 3.5 after that we're at a center line. 3.5 after that, and we're at a min. And 3.5 after that, we're here, and that's 14 minus 0. So there, that's everything that we need, and the spacing looks to be appropriate. Alright, the amplitude from 16 minus 11, 5 feet is the amplitude. Our center line is at 11 feet, and I just defined my center line to be there at t equals 0. So I'm going to reword that for you to just say, hey, pick your own starting point. Alright, my amplitude is 5. My period is 14. I didn't have any shift left or right the way I picked my point, and my center line is there at 11. So let's reduce the 2 over 14 to be over 7. x minus 0 is just x. So this is the equation that I would use to describe this. Alright, so hey, I hope that helps. I'll talk to you later.